Hello, today I'm going to be going over more or less how the game actually knows which functions to call when within battle. Well, not all of them, specifically the game code specific to specific moves, abilities, and items. I'm going to be working backwards from the actual specific functions, just using facade as an example, and move all the way back. So facade, like many moves and such, has actually two different unique functions associated with it. One is the one that ignores the debuff to attack from burns, and the other one is the one that doubles the move's power if there's a status condition. So at the very base level, you have the actual specific function. You can see I figured out a little bit of what's being called where. This is just takes looks at the attacker, um, and literally just sets a flag that ignores the burn debuff. The power boost checks if the attacker has a major status condition, and if it does, it branches off to just double the move's power. Um, Back one more time. So that's the very bottom level, the actual base unique functions. One level up from that, is a bunch of tables. This is at least for moves. It's for some reason not one nice big continuous table. It's broken up in a number of places by um, tables for specific moves. For example, flail and reversal. Look up this little table here to figure out what power to use. So not one. It's not one continuous table, and unfortunately, does not have a nice single specific reference, which is a little bit annoying. But it really couldn't have that anyway, as you'll see in a few moments. So in any event, the way that the game knows to call the correct function at the correct time is that each function you see there has the function's actual start address here. This is little endian, so you'll see this is 7A9 7C, and that is indeed where this function begins. The For the 4 bytes before each function call address essentially define a specific timing where when that function should be called to see if it and so or at least should be called. For so A number of them, I infer, are essentially specific points when it's actually running the damage calculation. 4-7 is, generally speaking, is a very specific doubling power. Timing 4A is called, when it's actually calling the attacker's attack stat. It's deciding. Well, this is well not this. This is presumably called exactly when it's checking to see if it should apply the burn attack debuff, so on and so forth. There is a lot of timings, as you can see. Like there's um, well over 100. You can see like the highest none I think I've seen so far is like BF, which is what's that? No, there's very least nearly about 200 of these. It is critical that you have if you're making a custom function or you're trying to get a specific move to, like, say, activate in a different way. Having the correct timing is crucial. I For example, if you have the move, let's say Psycho Shift, I believe I have gone over this before a little bit, but just to reiterate, say Psycho Shift has a unique effect, transfers a status condition, and I believe I have put that into my chart here. I misspelled Psycho. There we go. So see, this timing is BF. So if I was to change to, say, be a physical move and set to only damage, which is the way that damaging moves that have special effects are entered in the actual move table Gark. Then this effect would not run properly because this BF code only is, I wouldn't say only is valid, but it only actually functions properly if it's associated with a move that's a status move. However, you can, if you're trying to change something like that, you can try and find something that does the same kind of thing and see if it has a different timing code. For example, So when I was experimenting with this, I was like, okay, so what if I look for a move that has a special effect that inflicts a status, like Tri Attack. So Tri Attack has this code A1, and in fact, if I change the um, BF at the address associated with Psycho Shift to A1, and then change Psycho Shift to a special move or a physical move, then in fact it will do damage and transfer status. So that's just an important thing to be aware of if you're using existing effects and trying to like have them work at a different time or with a different category of move. And if you're coding an entirely new effect, this is also something to keep in mind. You will want to look for other moves that do kind of similar things in similar ways, and honestly then there's probably going to be some guess and check of trying to figure out exactly which code will actually be the one that works. I assume at some point we'll actually figure out what these mean, and like or at least like have a nice chart of like what kind of things work when. But for now there's going to be some degree of like guess and check. So in any event, so that's kind of how this works. Now moving one level up, um, every single move with a special effect and ability and item as well has this associated calling function. What this does is it does two things. First, it takes a small integer and stores it at some location in memory. This is this R0 this the actual location defined by the function that actually calls this, which we'll get to last. And then it takes this pointer over here and also stores that, and also picks it up into a register, and then once it returns to the function that calls it, then this is also stored in a memory location adjacent to this. And what this does is this is the pointer just to on the table we were just at, and this number is literally just the number of functions associated with the move. So for Sab there are two functions. So together this basically says, okay, when you're for a Facade, which you've just loaded because some Pokemon in the field has it, just jump to this address and look at the first two entries in this table, which is these two functions. Pretty straightforward. So this is pretty straightforward. Like every single one has this thing. The Battle of the Tiro is filled with a lot with literally several hundred of these little functions which just move this parameter. It's like number of functions, load this pointer, return. Now these are all defined in another table. Now here at least it's one contiguous table. There's one table for moves, one for abilities, one for items. And you can see that a lot of these I haven't like actually worked out who belongs to who yet. In here you see that I actually do have everybody like worked out. This is because I literally just copy and paste. This is because here it's the same format. You have a pointer, in this case, to the associated calling function, and before that is yet another much smaller number here. These are actually very straightforward. This is literally just the index number of the associated move. ED is hidden power. 0701 in Little Indian is Facade. So I literally just copy and pasted the entire block of hex into Excel and just made a bunch of formulas. So I don't look up tables. So this is just like grabbing all the move names. I've been working through these because I technically could just write up a script that would in Gidra that would take care of this, but there's a lot of information that I want to record in a nice chart, and a lot of other stuff I've been researching on, so it's just been actually simpler to do the very tedious manually go through all several hundred of them. Unfortunately for each game, this is for Ultra Sun, Ultra Moon, we're gonna need to do the same exact thing for X, Y, and ORAS. I know there are people working on those too, so it's really just going to be a question of harmonizing all of our data and compiling it into a nice single big thingy to easy reference. So yeah, so this is basically this is the move call table. Each of these three tables is itself associated with basically a master function that's called you can see it's called by a whole bunch of functions here. These are all, although actually these all seem to be the same function in different contexts, but you see there's a couple of different functions that go and try and load moves. As far as I can tell, based on basically when the game crashes, if I break this on purpose to see what happens and such, as you might expect, the ability thing is run through and checked basically as soon as the battle starts. Uh, moves are moves are called basically as soon as you hit the fight button in the menu. Items are at some earlier timing. For reasons I don't quite understand yet, each of them, when it breaks in in a slightly different way, which I will get to in another video when I'm talking about actually like more complex stuff. But I mean, essentially, all three of the loader and the master loader functions have the same format. First, they load this a pointer, which is the pointer to the start of their like of the big table with all the index numbers. Then there's a parameter. In this case, it's loaded by a loader function, but only because one hexadecimal 157 is too large just for a simple compare function, so it has to load it into a register. And then it just does this big loop where it grabs the next entry in the table, checks to see if that entry is equal to the index number. You can see that like this right here is the move index number that's coming in. So it checks if that entry is equal to the index number it's currently looking up. If it does, if it is equal, I don't actually understand what this entire block here is doing. It's doing something with I know it's doing something with one of the major pointers to like the data loaded from the save. What it's doing with that, I honestly do not know. I'm trying to figure that out because something about this is breaking when I try and move the move and ability tables as of the time I'm recording this video. So I can't do that right now. I'm working on a workaround in the meantime. This call conversion is just Ghidra hallucinating a little. It just thinks it's looking to call that conversion because that's the first item in the table. So basically, if it finds a matching index number, it looks at the next 4 bytes after it looks at the next word in the file. Loads that pointer into R1. Branches to actually like run that function. Comes back, stores all that information in the stack, and then returns to wherever it came from. And then I actually have not found the function associated with this, but at various points, during when it's like doing stuff during battle, it will then be like, okay, again, yeah, I'm at timing like A1, run through all the functions I stored. Is there an A1 in the house? And if it finds one, then it runs it, and it will check to see if it's the right time for it to run, and if it works, then it does whatever it's supposed to do. So there's one major thing to keep in mind. I will assume you've watched the relocation patch video if you're watching this one. So all of these pointers I've been talking about are all things written by those relocation patches. If you look at these equivalent things in an unloaded file, or if kind of just open up Battle Hero in a hex editor, or even Ghidra, all of these will just be 0, but they're completely unloaded. So you're going to have to extract a loaded memory dump, which I will make a tutorial for at some point, in order to actually map out where everything is relative to each other. And that's why I have these 2 columns. This is the address when it's loaded, at least in the version of Citra I'm using, blah blah blah. This is the equivalent address in an unedited battle.cro, with one that hasn't had any of its sections expanded. So that's just something to keep in mind. With Citra and at least my new 2DS XL, the offset, the difference between these two is hexadecimal 6DD000. I've had to type that so many times it's burned into my mind. So that's something to keep in mind if you're researching this yourself. So the okay, actually that will be the next video. So let's close it here.